A wall of 19,000 tiny lights, arranged like a cortex. Most of them sit dark. Then you ask a question, and across the wall, dozens of lights flash white, one after another, rippling in patterns as an answer forms word by word. Every flash you're watching is a specialist waking up inside a 744 billion parameter artificial intelligence. That's not a concept render. That's a real screen, running on real hardware. And as of this week, you can open it on your own machine. It's called the Brain Page. It just shipped in version 1 of Colibri. And it might be the closest thing that exists right now to watching an AI think. If you're new here, Colibri is the tiny, pure C engine that broke the internet this month by running GLM-5.2, a frontier-class 744 billion parameter open model, on an ordinary computer with about 25 gigabytes of RAM and no GPU, by streaming the model's experts off a fast SSD. The full breakdown of how that impossible trick works is the most watched video on this channel, linked in the corner. Today is not a rerun. Today is what just happened next. Because in the week since launch, this project added over 13,000 GitHub stars, roughly 1,900 a day, shipped a major release, ran a fascinating experiment on a 6-GPU monster, and published one failure so honest it deserves its own chapter. All of that in the next few minutes. Start with the release. Colibri version 1.0 introduces a single new command, ColliWeb. Run it, and instead of a plain terminal, you get a live dashboard in your browser, token-by-token generation metrics, a hardware panel showing exactly what your machine is doing, and a live map of the model's memory hierarchy, which pieces are sitting in GPU memory, which are in RAM, and which are out on the SSD waiting to be called. The engine that famously has zero dependencies now has a face. And then there's the page this video is named after. The Brain Page renders every single expert inside GLM-5.2, all 19,456 of them, as a living cortex on your screen. Here's how to read it. Each dot is one expert, one small specialist network inside the giant model. The color of each dot tells you where that expert physically lives right now, the fast tier in GPU memory, the middle tier in RAM, or the slow tier out on disk. The brightness tells you its routing heat and how often it's been getting picked recently. And when the model generates a token, every expert that actually fires flashes white. Sit with what that means for a second. A mixture of experts model works by routing. For every token, a tiny gatekeeper picks a handful of specialists. In GLM-5.2's case, 8 routed experts plus 1 shared 1 per layer, and only they do the work. We've explained that with words and diagrams for months, on this channel and everywhere else. This is the first time a mainstream tool just shows it. Ask a coding question and watch one neighborhood of the cortex light up. Switch to a question in another language and watch the glow migrate to a different region. Keep a conversation going and you can literally see the engine learning your usage. The hot experts brighten, get promoted from disk into RAM, and the whole map slowly reorganizes itself around you. That learning cache, the trick that cut cold start latency by roughly 73% after a few sessions in community testing, used to be an invisible optimization. Now it's a light show you can watch happen. I want to be careful and honest here, as always. Seeing which experts fire is not the same as knowing what the model is thinking. Interpretability researchers would rightly call this a visualization of routing, not of reasoning. But there is something genuinely valuable, and honestly, a little moving, about the black box getting a window. You develop an intuition for the machine, and intuition is where understanding starts. It's practical too, not just pretty. Watching the tiers tells you exactly where your setup is starved. If your answer crawls while a wall of disk tier experts keeps flashing, you're watching your SSD be the bottleneck in real time. And you're also watching the case for more RAM make itself. Community testing already found that on smaller 24 gigabyte machines, the expert cache caps out early and decoding stays cold. On the Brain Page, that stops being an abstract warning in a README and becomes something you can see. It's a diagnostic tool wearing a planetarium costume. Now, Chapter 2, the GPU experiment. Because a fair question after the launch was, fine, it runs with no GPU, but what happens if you give it several? The Colibri team published the full logs from a 6 RTX 5090 machine, and the numbers tell a great story. In the morning runs, streaming from disk as usual, Colibri managed 0.12 tokens per second, while a specialized GPU serving stack on the same machine did around 2.5. Not a flattering comparison, and they printed it anyway. But in the afternoon, they tried something different. With 6 GPUs worth of memory plus system RAM, the entire model, every expert, could be held resident, with the disk removed from the decode path completely. Result, 6.84 tokens per second on a single request, the fastest number ever measured on that machine, from the same tiny C engine that runs on a laptop. And on the new dashboard, that's over 4 tokens per second end-to-end. Genuinely conversational speed from hardware that costs less than one Enterprise H100 card. The same engine now spans the full range, from a 25GB laptop crawling at a token every 10 seconds, to a prosumer rig you can actually chat with. And now the failure, because this channel celebrates honest engineering, and this is a beautiful specimen. Colibri ships with native speculative decoding using GLM-5.2's built-in draft head, a feature that, on the laptop setup, meaningfully multiplies effective speed. So the team tried it on the 6 GPU rig expecting another boost. It lost, at every configuration, and their published conclusion is the kind of sentence you almost never see in AI marketing. The failure is structural, not a tuning problem. Here's the plain English why. In a dense model, verifying several speculated tokens at once is nearly free. The batch rereads the same weights one time. But in a sparse expert model, every speculated token routes to different experts. Verifying 5 guesses doesn't reuse the work. It multiplies the expert loading. The very sparsity that makes streaming possible is what makes this particular speed-up backfire at scale. They tested it, they measured it, they documented exactly why it can't work, and they moved on. That's the open source difference. Failures become public knowledge instead of buried benchmarks. And every similar project now gets to skip that dead end for free. Which brings us to Chapter 4, because Colibri is no longer alone. In 1 week, it's become the flagship of a small movement. A project called flash-moe is attacking the same problem with a different strategy and reporting over 5 tokens per second on an M3 Max laptop. Another, called Hypura, is generalizing SSD streaming beyond one model. An integration with OpenCode, the open source coding agent, is in review, which would let this local giant plug directly into real developer workflows. And the community is even rethinking the interface itself. Several developers argued that a chat window is simply the wrong shape for a model that thinks slowly, and that the right pattern is a ticket queue. Submit your hard question, walk away, collect a frontier quality answer in an hour. Not a chatbot, a colleague who works while you sleep. For batch jobs, overnight document runs, and privacy-critical work, that reframe quietly makes slow local models completely practical. And Chapter 5 is a date, July 27th. That's when Moonshot has promised to release the full open weights of Kimi K3, the 2.8 trillion parameter giant we covered earlier this week. K3 is nearly 4 times the size of GLM-5.2. Its weights will be well over a terabyte, even heavily compressed. No consumer machine on Earth holds that in memory, which means the entire question of whether ordinary people can ever touch that model comes down to exactly the technique on your screen right now. Can expert streaming survive 2.8 trillion parameters? 9 days until we find out. And when the weights drop, you know exactly where the follow-up video will be. So step back. A week ago, Colibri was a clever hack, one developer refusing to accept that frontier AI requires a data center. Today, it has a dashboard, a visible brain, a GPU story, a published failure, a growing family of rivals, and a date with the biggest open model ever made. But the thing I keep coming back to is that wall of lights. For years, the entire experience of AI has been a text box. Words go in, words come out, and everything in between is somebody else's secret. Now, on hardware you own, running weights you own, you can watch the machinery of intelligence flicker. Every specialist, every decision, every flash. It doesn't make the model smarter. It makes you less blind. And in an industry that mostly asks for your trust, a tool that shows you what it's doing is quietly revolutionary. So here's my question for you, and I'll pin it below. Does watching the machine think actually matter to you? Would you use the brain page, learn its patterns, build that intuition? Or do you just want the answer as fast as possible, and the lights are a gimmick? I genuinely think this splits developers down the middle, and I want to know which half you're in. Everything in this video, the Colibri repository, the version 1 release, the full 6 GPU experiment logs, and the community projects, is linked in the description so you can verify every claim and try the brain page yourself. That's the standard on this channel. If you want the stories behind the tools everyone else just reacts to, sourced, honest, and in plain English every single day, subscribe. I'll see you in the next one.